Good afternoon, everyone, and thank you for joining us for today's webinar. My name is Josh Vickers, and I'm with RTI International's Forensic Technology Center of Excellence. Today's webinar is entitled Network Forensics, Challenges and Tools. We do have two subject matter experts for today's webinar. Our first subject matter expert is Dr. Catherine Siegfried-Speller. She is an associate professor in the cyber forensics program in the Department of Computer and Information Technology at Purdue University. She's also a member of the Tippecanoe High-Tech Crime Unit and has special deputy status for the Tippecanoe County Prosecutor's Office to assist with the High-Tech Crime Unit's criminal cases involving child sex exploitation. Dr. Siegfried-Speller co-authored the book Cybercrime and Digital Forensics, and she is a fellow of the Digital and Multimedia Science section of the American Academy of Forensic Sciences. She is also a member of the International Association of Law Enforcement Intelligence Analysis. She also serves as an editorial board member for the journal Digital Investigation. Our second presenter of the day is Dr. Justin, Dr. Justin Yang. He is an associate professor of Computer and Information Technology at Purdue University. His research interests are in cybersecurity, cybersecurity education, big data security analysis, SDN, Internet of Things, and cloud computing. Dr. Yang was a member of IEEE Cybersecurity Initiative Steering Committee and the project lead of IEEE Tri-SIB-C from 2015 to 2017. He currently is serving as the faculty lead for the Polytechnic Research Impact Areas in Holistic Safety and Security. Just our quick disclaimer, the opinions, findings, and conclusions or recommendations expressed in this presentation are those of the presenters and do not necessarily reflect those of the Department of Justice. Any products and manufacturers discussed are presented for informational purposes only and do not constitute product approval or endorsement by the U.S. Department of Justice. And now, without any further ado, I would like to hand the microphone and platform over to our first speaker today, Dr. Catherine Siegfried-Speller. Dr. Siegfried-Speller?
Okay, let's get this started. Thank you everybody for joining this webinar today. Josh, can you see the screen okay?
Yes, ma'am, we can.
Perfect. Okay, so Justin and I are going to talk about network forensics challenges and tools. We have a couple times where we have 2 poll questions, so we really hope for your participation and feedback. And again, Josh is going to be giving us what it is that you respond to as far as our questions. We really hope that you will take the time to participate. So an outline of what you can expect for today's webinar. We're going to go over network forensics, the challenges within the field of network forensics as far as research and law enforcement is concerned. We're going to talk about some of the network forensic tools that are available, their limitations, and then we're going to talk about a tool that Justin and I worked on along with several other research faculty at Purdue University and created FileTSAR. So we're going to talk about this tool that is available to law enforcement for free, and we'll also give you a way to contact us to obtain this tool. And we'll also talk about where we see the network or the future of network forensics. So first, before we get into network forensics, I really like to talk about this unique partnership that we have at Purdue University. And so as Josh mentioned, I'm a member of the Tippecanoe County High-Tech Crime Unit, so the HTCU. And the HTCU is a partnership with all of our local law enforcement within the county and all of the investigators that are also digital forensic examiners. So they're housed in a centralized unit at Purdue University. And what this does is it allows us to work with law enforcement for research purposes. It also allows us to assist on cases and provide graduate student interns. And so we're really lucky that we have an active law enforcement digital forensics unit on campus. The investigators are certified in a wide range of forensics or digital forensics, everything from video forensics to mobile and traditional computer forensics. And so again, a lot of the work that we do is because we have this unique partnership. And so I like to always take a moment to thank the HTCU for working with us on these type of grant opportunities. And so digital forensics. So digital forensics is really the science of investigating digital evidence. And when we first started talking about digital forensics, it was really based on computer or traditional computers, dead box forensics. And with the history, if you look at the FBI, the definition of a case that involved, a computer crime would have been the theft of computer components. And so we have really moved away when we look at the 70s and 80s definition of what is a computer crime or what is a crime that involves computer evidence. We've shifted quite a bit away from that traditional thinking of it being theft of computer components to a wide range of digital evidence. And so now digital forensics is really an umbrella term that we use for subdisciplines, including computer or dead box forensics, mobile forensics, malware forensics, multimedia forensics, which will include audio and video enhancements, and also wireless forensics, which again often includes IoT devices, for instance. And just like the traditional field of forensics, it involves similar procedures. We're interested in identification of evidence all the way to how do we present that evidence to a jury and to a prosecutor. So Justin, I'm going to bring this to you.
Good afternoon, everyone, or good morning if you're coming from a different country. My name is Justin Young. It's a great to talk to you and interact with you in today's seminar. So I'm going to, Catherine and I were kind of, work together on this presentation. So I'm going to talk about a few more slides on the IT landscaping and kind of survey a bunch of different network forensic tools. So first of all, let's think about how the IT landscaping is currently changing. Before, when we talk about computer forensics, we're talking about inspecting all the different parts of computers and all that, but not anymore, because if you're thinking about today's computer, it's all about cloud computing, about mobile computing, IoT, machine learning, and edge computing. So digital forensics is no longer just a tool or technique that you apply to standalone computers. And with the cloud computing, it brings up a lot of challenges. The virtual machines are typically cloned from images, and they all pretty much look the same. So all the technique of doing operating system fingerprinting will make it very difficult. How do you distinguish this, right? And with the cloud computing, you got your virtual machines to move around quite a bit. And you have, you might have VMs moving from one site to another. So how do you actually convince people this is actually the virtual machine that the criminal used? So there will be a little bit more challenge on those. And from networking perspective, people have so many different ways to kind of get connected on the internet. So you have your cellular network, Wi-Fi, and you also have some other communication channel like Bluetooth, NFC. So that makes the whole thing a lot more difficult. And the routing and the network address translation, making this whole thing even more complicated. In some cases, some of the virtual machine traffic, if the both virtual machines sitting on the same physical box, that network traffic never leave its box. So there are many, many different challenges in today's IT landscaping. However, it also brings a lot of opportunities. For example, with the cloud computing, you can actually store all the VMs. The VMs contain the evidence. You can store all those in the cloud, encrypted, and put the hash code in there. It will make your chain of custody a lot easier. And with this distributed storage capacity, you really have the true capacity of C2 level logging for those database servers. So that's something that could be really hard to achieve in the traditional computing environment. Next slide, please. So before we move on, we would like to set up a poll question. You do not have to respond, immediately, but thinking about it, what are your agency's biggest challenges with network forensic investigation? So that's the poll question. Take a look at it, think about it, and please answer your response from the chat box. And I'm going to talk about a few more slides on the network forensics, and we'll come back to this poll question. So for the network forensics, we typically have two different purposes. One's for intrusion detection, the other is for criminal investigation. For this audience, let's just simply focus on the criminal investigation. So when it comes to criminal investigation, there are basically 4 different tasks related to law enforcement. You want to capture network data to prove who get what IP, who kind of have what kind of presence at network level, and you want to do a network traffic analysis and see what is going on. And if the files are being transmitted in the process, you want to be able to assembling this whole files and reconstruct it, because for us to do investigation, it's not about network packets. It's about what the information this potential criminal conveyed to the other victims. So those are the four very important tasks for network forensics. And the benefit of network forensics is actually pretty obvious, because thinking about the days where you don't have the network tools, what happened here is, if the people have the knowledge to be able to erase some of the information from the computers or the servers, and there's no way you can recover it if the people have the right knowledge, but not so much for networks. So if the network data, if somehow you're able to capture data, I don't think the criminal will have the ability to erase the data you captured. So even though network data is kind of volatile, dynamic, but as long as you have that kind of network capture, that certainly give you additional advantage. Another thing I also want to point out is there's a lot of debate in terms of how should we treat the computer records. Is that should it be a direct evidence, or is it hearsay evidence? Historically, the computer records are not treated as direct evidence, but we see this trend is actually moving. So people begin to treat computer records differently, putting them into two categories. Is this computer generated records or computer stored records? Is it computer generated the records? Chances are you're more likely this record can be treated as a direct evidence and is admissible in court. This is very, very important for law enforcement professionals. If it's something that you found on the computer, that's something we call computer stored records, and then you actually have to do additional work and try to prove who created that data, and the data itself is reliable, trustworthy, not modified. And for that, we have tons of different tools available for that purpose. But what really the network forensic offers is some of the additional things that's probably not be able to observe from the local computer, and also make your case a little bit easier to justify in court, because that's a computer system generated records. Next slide, please. So we're going to review quite a few network forensic tools. Let me first begin with this open source tools. And perhaps the most widely known tool is this thing called TCP dump. It is the grandfather of all open source packet sniffers. It was written 33 years ago by Van Jacobson. Because I'm a network guy, I know this Van Jacobson did tons of work when it comes to TCP IP. The work was developed from Lawrence Berkeley Laboratory. Part of the limitation of this particular tool is it's a command line tool. And if you see the output on the screen, it shows you the timestamp, IP address, acknowledge number, window size, and all that. Honestly, it really needs somebody to have a great knowledge to understand what's going on. But the command line utility, this particular command line utility was first just made available to the Unix and the Linux system. And people said, you know what, I'm using Windows computer. For that reason, people also developed the Windows version of the tool. Now, in today's switched networking environment, TCP dump is actually pretty limited, because it can only see the traffic that's addressed to it itself, or some multicast traffic or broadcast traffic. So really there's not much you can do unless you just want to study what exactly are the things sending out over my network. So for investigation purpose, you pretty much have to rely on a tool or some function called a spam function, or call it switched port analyzer. So you actually do a mirroring the port. You have to transfer the traffic that's routed to supposed to be routed for somebody else, and download and forward to a storage unit. And this particular TCP dump does not have the ability to do any additional analysis. You cannot really put together all the different pieces of packets together to reassemble file. You're going to need additional tools like a TCP preplay or TCP opera to do some additional analysis. But this basically is the foundation that kind of making today's network sniffer possible. On the bottom, on this second, on the lower part of the this particular screen, you see the Wireshark, and I know many of you are familiar with Wireshark. This is such a wonderful tool. It is feature-rich, extremely powerful, and it's supported on both Windows, Linux, and Unix. It's widely used by academia, network professionals, and it's free of use under the GNU GPL version 2. And it can be used for doing a lot of wonderful things. However, it does have some problems or concerns, even though it has a very way better user interface, because it organizes your content based on the binary information, and also provide you information about what the number of the frame, whether it's an Ethernet frame or some other frame, whether it's a TCP, IP package or something else. It gives you all the full details. However, there are a couple of things will potentially be a burden for law enforcement professionals. First of all, the Wireshark, in some cases, need administrative privilege. So thinking about this, and if any of the security risk and the person running the application as an administrator, and that could be a nightmare if you're running this as an administrator. So Wireshark acknowledge that's a very big concern. So they do give you sort of option, so regular use can run this, but regardless, there are something that we have to be worried about when it comes to Wireshark. It is written in C, so it has a great performance, it's super fast, and also have very good capability. However, it has a poor security. So anyone who have the experiences writing your application in C, there are many things could go wrong with your C code because you have too much freedom. Buffer overflow could happen. Type checking are typically not there. Range checking is not there. And this particular tool, as of right now, you're looking at millions of code, and is contributed by a wide range of developers with all the different expertise. So the Wireshark, some portion of it could be very solid, but some functionality might have a very weak when it comes to a security perspective. So this is something that I want you to be aware. Wireshark is very, very feature rich. It also has a lot of utilities. For example, Wireshark came up with a T-Shark utility, which is some of the utility that we actually use to build a FileTSAR program. But regardless how powerful the Wireshark is, it doesn't really give us the full thing. To be able to do law enforcement investigation. It has a limitation in terms of reconstruct the files, and doesn't really generate the reports for us, but it's a very good starting point. Next slide, please. So we have 5 more utilities to look to here, but if you actually do a little bit survey on the literature, the list can go more than this. I just want to give you a few kind of snapshot so that what are some of the limitations of those open source tools and why they're not become such a popular when it comes to network forensics. So network miner is one of the really utility tools. It's on the left, the top, this purple icon. And they have both free version and a paid version. Paid version is about $900. And among all the differences, the biggest limitation is that the free version, you cannot export the data. So, and there's no search. So for law enforcement, if you're using the free version, that's basically no-go. Because if you cannot export data, you cannot, protect it and use it as digital evidence. There's, really no point to use this for the free version. The paid version does provide that kind of functionality, but the search functionality is not there. It's just not a great tool when it comes to forensics. The second tool on this slide is something we call the Kismet. It is mostly for wireless network, and it suffers from the small coverage area and often takes a very long time to discover all the different networks. But if you really want to do the wireless network forensic, this is one of the tools you can consider. And the second tool that's related to wireless network is our third icons on this slide. Is the Net Stumbler. So this is actually something that we teach in our students in the classroom to investigating whether there are rogue access points for the wireless field site survey. And this is actually a great utility for network engineers to troubleshooting, see the signal strength problem, but not so much for the law enforcement purpose, mostly because when it comes to word diving, it's more recreational, it's not really professional. And biggest problem for that utility is it is not 100% passive. It will send out active probe. And that could be a very big problem when you have something, you try to present in the court and people say, what? You have some active probes in your evidence. That's totally not acceptable. So this basically is a no-go from a criminal investigation purpose. The fourth tool we'll look at here is that little monkey. I just like this icon, and I thought it's very cool utility, but honestly, it's not very powerful. And it's one of those network sniffers, but it has a graphic UI. It is more about network topology rather than doing the network forensics, but it's an interesting utility. You can give it a try. And on the right side, we have this snort, this little piggy icon here. And this is probably many of you familiar with one of the greatest tools when it comes to network investigation, and people use snort on all different occasions. And it basically can be considered as a network sniffer and a firewall, if you may. So it supports 4 different modes. You can do a sniffer, so it can read the packet sending off on the network. You can also configure it running as a packet logger mode, so it can capture and log all the packets into a disk. And you can also using the snort configure as a network intrusion detection systems, or sometimes we call it NIST. So the snort can actually analyze the network traffic and searching for all the different patterns and see if the network's being attacked or need to do something. And the forward mode for the snort is you can configure it to run it in the inline mode so that packets can read rules from IP tables or something like that. So if certain things match the criteria, it will drop that particular package, and this function very much like a firewall. So for network forensic examiners, and typically what we use snort is we use the network intrusion detection mode because it's not really invasive, and attaching this device to organization is very easy to do. So you don't have to do a lot of things to make that happen. But again, the snort is more generic tools, kind of like Wireshark in a certain way. It doesn't have those specific function that's built for law enforcement investigation. And I think, I think all those different tools have one weak spot is it doesn't really give you the functionality to reconstruct the files, and it doesn't really generate the report. So those are the common weakness in open source tools. So let's move on to the next slide. So for many of the law enforcement, when you do the investigation, what you really want to hope is your tool is court admissible. So you don't have to explain to the judges and the jury that what kind of tool you use. How do you, how much confidence you do have? So on this one, we have a commercial tool called Net Witness. And this is actually something very interesting that basically shows you how the technical field is moving. So the Net Witness is started off as by CTX as a company at the DC in the 1990s, acquired by Mantac, and later on spinning it off as a standalone company. But it was actually one of the fastest growing company. And it was later on acquired by the EMC in 2011. And we also know that EMC bought RSA. So all of a sudden, this Net Witness has become a product kind of merged with RSA. Now, the thing I want to mention this is actually from a certain perspective, I was a little bit disappointed because if you see the icon here, before this EMC purchased Net Witness, you actually have a pretty good tool that can be used for doing network forensic investigation. You have your import package, you do collection, you can search, you can navigate, you can analysis, you can export your data into PPAP format. That's actually a perfect tool for us. But once the RSA took over, they completely, changed the scope of this this particular tool. So nowadays, the RSA net witness is more like a threat intelligence tools rather than a forensic tools. So they more focus on the security information and event management rather than, try to capture what's going on. So this is one of the commercial network forensic tools. The second network forensic tools is on the next slide. It's called Splunk. So next slide, please. Oh yeah, it's already here. The Splunk is something very interesting. It was not meant to be a network forensic tool. It is actually a tool to be able to capture, index, and correlate real-time data in a searchable repository. So going from there, you can create a graph, reports, alerts, dashboards, and visualization. So if you have the money, I would strongly recommend you look into Splunk because it's super great. It's built on top of this big data platforms and all that. However, this thing is really expensive. So last time when I checked, the pricing starts at $2,000 per year, and only support like 1 gigabytes of data per day. And if you're looking at Xfinity, the average user, home user, they're going to consume more than 300 gigabytes per day. So put differently, if you're going to analyze 1 gig, if you are paying $2,000, that's just enough for you to pay for average home users network traffic. So this could be really, really expensive. So if you're looking at enterprise environment, if you're thinking about Purdue Research Network, the amount of traffic you're looking at here are typically in a range of 100 gigabits per second. So in that range. And let's turn on to the next slide. So in addition to those different tools, I also want to highlight something could be important if you're trying to do investigation and at the enterprise level is you have to have a hardware level of tap or network devices. The reason is because if you don't have this kind of expensive devices like the picture we're showing over here, the ProfiShark is about $2,500 and only supports the throughput of 1 gigabits per second. In enterprise setting, you have in days probe that costs around 100K or even $500,000. So they are really expensive, but there's a reason for this because the spamming or the mirroring technology on the switch, they're going to drop the packets if the package is overloaded or packets have corrupted or below the minimum sizes. Only this hardware level tap devices are able to capture all the traffic unmodified, without modified timestamp, be able to show everything to the court. Because some knowledgeable attorney, they might cast a doubt about the spanning port and all that different things in the court. So they're going to say, when you're using the mirroring or span, it's going to change the timestamp slightly. Some of the packets might drop. The user they didn't even know the packets dropped. So they're probably not a very strong argument, but that's bad enough to present certain doubt to non-technical jurors. You really don't want to happen. So if you're for serious enterprise level network forensics, you probably have to put your money and do a little bit of investigation on this. So with that, I'm going to turn it over to Catherine. Okay.
Yeah, sorry, it wouldn't let me unmute without coming out of the screen. So let me go back to my current slide. There we go. So Josh, I'm going to come back to you with the challenges that our audience members have experienced with network forensics.
Sure. So we had quite a few responses, but it seems like the majority of the crowd is definitely chiming in on training and lack of expertise. Mm-hmm. Definitely having the proper tools is something else that was brought up. No IT person, so no dedicated IT person for that department, which then leads also into cross-training and training others so that there's not just that one person. Mm-hmm. So really obtaining proper training and equipment and the proper tools is something that most of the audience chimed in on.
Yeah, that's something that we echo with the high-tech crime unit as well. One of the reasons why we wanted to house everybody in the same space for that shared knowledge and cross-training that was mentioned. And again, so we didn't also have to have everybody from each agency specializing in network and mobile and computer, because if everybody's housed in the same place working together, then it's much easier to share the tools and also that knowledge. So, well, one of the challenges that was brought to us was through an NIJ grant. And the challenge that the National Institute of Justice sort of posed was developing a network forensics tool that analyzed or handled modern day large scale computer networks. And so they were challenging researchers with development of a tool that works with 5,000 computers or more. And they also then within this RFP or request for proposals asked for it to be cost efficient. And then, we also added as researchers the idea that it should be admissible in court. So if you're developing tools for law enforcement, we need to also be making sure that it's not just, going to overcome that financial burden, but it's also going to be forensically sound. And so Justin and I, along with several other researchers from Purdue, were lucky enough to receive this funding from NIJ and to sort of combat this challenge. And so that's what we're going to talk about, which is our development of FileTSAR. And so again, with these challenges of network forensics, we also have the issue of big data. And I know Justin briefly mentioned this, and big data is usually characterized by the V's of big data. And the big data problem could be summarized by 3, but what's really interesting is that researchers have expanded it from 3 to 7, as in the image that I have here on the slide today, all the way up to 51. And so this is an incredibly complex problem because as technology is changing and it's increasing, we're then able to have more data. And so in general, though, when we talk about big data, we're talking about volume, velocity, and variety. And so we're talking about the size of the data, the speed of the data, and also the trustworthiness of that data. And again, this is one of the major problems that we also had to consider when we were thinking about developing a tool that met the needs that the NIJ requested. And so our objective was to look at a tool that met the computer forensic field triage process model for investigators. We wanted it to be able to capture network traffic. We wanted it to be able to analyze that traffic, maintain the source, and also preserve admissibility of the evidence. And again, it needed to be able to handle large-scale computer networks for investigations of 5,000 computers or more. When we started working with this, again, we wanted to make sure that we had law enforcement in mind. And so from the very beginning, we actually partnered with the NW3C. And then again, we worked with the high-tech crime unit at Purdue to make sure that they were giving us feedback throughout the tool development process. And they also acted as our beta testers. And so again, we were very mindful, making sure that law enforcement, we kept them in mind as we developed a tool that met the needs of the NIJ RFP. And so our solution was FileTSAR. And so FileTSAR in the top right corner of your slide, here is our logo. And so Justin's going to talk a little bit about this in more detail on the next slide. But it's sort of a nod to our ability of incorporating some open source tools. And so one of the things we thought is if we have to keep in mind the finances of law enforcement, then maybe we can create custom code wrappers that essentially took all these different open source tools and had them work together. And so here in our logo, you can see, as Justin again will talk about in the next couple slides, we have our little shark fins, and so that's a nod to Wireshark or T-Shark specifically. And then the elk horns in the center is Elasticsearch, which is a part of the elk stack. And this is, again, our attempt at making something that we thought was going to be financially affordable for law enforcement and also meet the needs of the RFP for NIJ. And so we wrote these custom code wrappers that got these open source tools to communicate together. And what we did was we allowed for the capturing of data flows, analyzing the contents of those flows, and then finally the big thing that NIJ wanted was reconstructing of files. And so we were able to do was reconstruct documents, images, email, and VoIP conversations or VoIP sessions. And so Justin, I'm going to let you take it over from here.
Okay. So when we try to implement the FileTSAR project, and we basically have all the things that we have on mind, we try to capture, be able to have the tool be able to capture this and be able to do parsing. So putting all the different fields into our database, and going from there, we can be able to search analysis and be able to bring this data to the users through the visualization. So on the next slide, you'll be able to see the network architecture, or actually the system architecture. We kind of get rid of the web server, some of the storage unit in there. But basically what you can see from here is, by looking at a picture, at the top you have the T-sharp. As we mentioned earlier, the T-sharp is the utility, as part of the utility coming from the Wireshark. And this one will allow us to configure what kind of the traffic do you want to record, or are you trying to feed in the system with a pre-recorded message? So if you have something pre-recorded, the T-sharp will go directly to the Elasticsearch, which is our database, store everything with the indexer, and be able to reconstruct the files. And if it's a live traffic, we go through the right side, the path. The data will go to the Kafka, which is the kind of streaming surface interface for the Spark system. So we use a Spark for our big data platform. The Spark is very important. So if you're familiar with big data, you can realize Spark is actually developed kind of using the similar mindset from Hadoop. But for our researcher scholars, we kind of skip the Hadoop because it's horribly slow. Spark is really, with that in-memory computing, is really the system of choice when it comes to big data. So the right path is for live traffic, but eventually everything go to that Elastic search to be able to analyze and visualize. And on our next slides, we're going to show you the user interface. So to be able to access to the FileTSAR system, what you're looking at over here is you have to have because right now it's hosted on Purdue CIT, so you have to have a VPN access to Purdue CIT. Kate will be able to give you that information if you're interested to test out the system. So going to the, give you the right IP address and port number, going from there, you'll be able to access the file system as long as you have the login credentials. So going from there, the system will allow you to do data collection, do visualization, do file constructions, and in addition, you can actually also see the file, the report. But the report is not something directly from the home page. You will be able to see this in a different, slightly different UI. So move on to the next slide. Let's spend a little bit of time talking about the data collection. So as we talked about before, data collection can be very, very important and very tricky. And so we have a consolidated with many different professionals asking them, hey, what kind of network traffic do you want to capture? So we realize people have a different need. They might want to capture the data based on time, or they may simply say, I only have like 10 gig of storage. Or other people say, you know what, I have almost infinite number of the storage capability. Let's just do it nonstop. So the tool with that kind of thing on mine, we will allow the users to configure the collection however you want. So on the next slide, you will be able to see is in this particular screen, this is where we're giving the user the ability to say, I want to capture everything based on time. I want to capture, for example, in this particular slide, capture 5 minutes of network traffic, and all the other settings are default. You're going to analyzing the web traffic, file transfer traffic, email, voice over IP, and so on. And the next slide shows you still the network collector, but then it will give you the option to say, oh, we're going to capture the network traffic up to a certain amount. And this is really important if you have limited storage. So here you have 500, 1 gig, 2 gig, 5 gig, and custom. And in addition to this, I think we can also configure based on, you can also configure nonstop. So next slide shows you can do this on nonstop. So that will give you the ability to kind of sniffing the network traffic all the time. And this could be handy. Yeah. So once you configure everything, you actually have to hit the green capture button to do it. So that's some of the options in addition, you also get to choose where, if you have some of the files already pre-captured, you will have the ability to feed collectors using this pre-recorded traffic. You will give it a casting name and click on that choose file button. And yeah, this name is, we're still using the capture as a name, but it's actually more of the uploading. We didn't change the icon, but for the unit, for making the UI look consistent. But this capture really means, read the data, pre-capture the data. And what we found out was actually in real life, a lot of the folks really like this feature because part of the limitation of our tool is the whole thing when you try to deploy to an organization, how do you actually capture network traffic? It's not something that you can just simply copy paste. An IT person or security person have to be able to configure the settings and to be able to start sniffing the traffic. So having this option actually make law enforcement folks very happy. And once you're having this kind of a collector, this is how it looks like when the capture start doing its work. There will be icons showing it's doing the collecting, waiting for the collections and all that. And that's pretty much showing you the capture status. And you can always confirm this from the capture status. And then moving on next, I'm going to talk a little bit about the indexer. Yeah, the index is actually very important. If you want to be able to search, you want to create index. Otherwise, this search will be very slow. And from the network perspective, we want to do two kinds of parser. One is be able to parse the individual packet. The other is try to parse the flow. The difference between packet and flow is kind of like, if you, for example, if you go to YouTube, you try to watch a video. Now the packets could be millions of packets, but it's considered one flow because you're just watching one video. So we actually need both of them. The flow will basically tells you what is going on, who talked to who, at what time, for how long. The packet actually give you all the content that actually happened during that kind of communication. So our tool are able to do this at both levels. So the next slide is talking about analyzer. So the analyzer basically just, we leverage some of the existing open source tools and we put the wrapper around, integrate all those different tools. So our tool are able to process the web page, the file transfer based on FTP protocol, and the email communication that's based on SMTP, IMAP, or IMF. Those are the protocols that we can handle. We do assume using the base 64 encoding for MIME header. If your email is using different encoding, that probably needs a little bit twisting. And our tool will also be able to looking into the protocol that speak in VoIP, in particular looking at the real-time transport protocol RTP, looking to UDP port number 7001. So we were able to decode that message and convert it to MP3 file for storage, and also for the law enforcement professional to look into the actual evidence. So those are some of the jobs for analyzer. And let's move on, looking at the how it looks like. So once it's actually finished capturing, finished analyzing, and reconstructing actually happen automatically, and you will have the choices on the left side to download everything, or you might want to take a look to see, hey, what exactly have I captured? What's in there? So by clicking that view button, you will able to see everything we reconstructed. So on the next screen, we have the user AI to show you. When you click on the view button, you will be able to see on the top, the files are separated by networking protocol. Is that the file transfer? Is that the voice over IP, web pages, or is it email communication? If you choose the web pages, if you click on HTTP link, and then you will be able to see next screen is what are different files, web pages are there. So we named the file based on IP address. So for example, the very first one is telling you you have an internal client visitor web server coming from 192.168.0.30 IP address, well actually 30.108 address, and connect to somebody outside with IP address 74.125.224 and 60. So that shows you who talked to who. And on the little bit to the right side, you have your download icon. So going from there, you will actually be able to see in that communication what are the files that's being transmitted between this client and web server. So this kind of setting is consistent for all the different protocols, and the download folder is actually, download the user interfaces actually look very similar, simple. You just simply say, hey, I want to download this. Where do I want to download it to? So this is actually pretty straightforward when it comes to downloader. And Catherine, you have a very nice video to kind of show people exactly how this works, right?
Yes. Let's see if I can get this to work. Let's see. Okay. So this video is just going to show exactly what Justin talked about, which is being able to view the data capture and reconstruction of files. And so here you can see the task name, the creator, the timestamp is when you started the capture. And so once you're all done, you're able then to go to, oh, sorry, moving. Go to download, or you can go to view construction or the reconstruction of the files. And so the reconstruction view button takes the user to the folder structure of the network capture. Each protocol will be saved in a different folder. You have the option to download each folder and its contents or view the file through the web browser by clicking the folder button under action. And so again, for each protocol folder you view, you will see the files that have been collected from the network capture. And you're able to view each file in the web browser if the view button is available. And if not, you will need to download each file separately to your computer. So in the HTTP folder, you can see PNG, GIF, and other types of files that were collected. In the FTP folder, you can see PNG and Excel files. And again, by only clicking the view button, it will open a new tab with the PNG files showing in the web browser. And if you click the download button, it will download the file to your computer, and then you're able to open and view that file on your machine. You're able to do this again for the SMTP folder to look at those emails. And the user can always select multiple folders and files and download them all at once if they wish. So here's showing your ability to select specifically what it is you want to download, if it's multiple folders, all at once. All right, Justin, I'm going to take it back to you.
Okay. For the time's sake, let's speed up. So we also have the visualizer thing. Next slide, please. Yeah, so basically we have the dashboard. This is using the Kibana. And going from there, we will have the dashboard to show people visually what's in there. And going from there, it will allow you to search based on who is sending what information. We pre-configure many filters to allow the user to be able to discover what's happening very easily. So yeah, this is actually something that most people really like, because you cannot really, as a regular user, it's just so hard for you to spell out the rules that you use for the networking settings. So all those rules are pretty much already can be plugged in. So all you need to worry about is who is the sender and what are the things you need to, what are the information you need to find out. And this visualizer really help people narrow down to see what's in this network capture cabinet. So once you are able to get all those different information, and I think our tool has something extremely unique. And I didn't find any of the things in other utility is the report, something that you can use in the core to present your case. So Kate, please talk about the report.
So once you are finished going through all the data, your PCAP files, the reconstruction, you're able to create a report. And so when a user is done looking through everything, you create this report for your packet capture. The report feature will create a PDF document that is downloadable and printable with valuable information about the chosen packet capture. The cover page of the report shows the case name, case number, investigator name, agency name, and the FileTSAR version, along with the date and time that the report was created. When you scroll further down, it will show more case information and case overview details. Further, you'll be able to see the visualizations that were made in and placed on the dashboard, the protocol information, charts, graphs, relevant search results, and activity log, and probably most importantly, the hash values of the packet capture file. So again, this was something that we thought was incredibly important for the tool to be forensically sound, was to make sure that we provided hash values. And so that's, again, something that we are really happy with as far as FileTSAR goes. Once you're done with you can always go back to, again, the main page. If you need to delete the report because you needed to go back in and add some other details, you're always able to do that. Just make sure I mention this. It does have an activity log, so it keeps track of everything that you did as far as when you were going through and looking at the reconstruction of files, when you captured it, how long you captured it. So provides a lot of great information, especially for it being forensically sound. Okay, so we have a poll question coming to our last question. Does FileTSAR fit your agency's network forensic investigative needs? And if not, what suggestions do you have? So again, does FileTSAR fit your agency's network forensic investigative needs? And so as we are collecting that data, I'm going to move on to the reconstruction validation part. So for time's sake, I'm just going to say that we tested whether or not FileTSAR would work on a large scale computer network. So what were the capabilities of it? And we found that it did work. And so Justin and I, there's a paper out there that we're happy to share with you that was presented at a conference that talks more about the reconstruction of this. And probably most importantly is the current status of FileTSAR. So FileTSAR is free to any law enforcement agency. We've had agencies, large and small, request FileTSAR, also agencies from all around the world. So please feel free to contact me at my email, kspeller@purdue.edu. You'll have to complete a license agreement for access to FileTSAR. Once you have completed the license agreement, I will send you a link and password, and you'll be able to download FileTSAR, the manual, the installation guide, and we also have training videos that walks you through all the different components of FileTSAR. And again, all of this is available online. Currently, we have over 100 law enforcement agencies around the world that have requested FileTSAR, and right now we have 30 agencies that have actually completed the license agreement. So we are incredibly excited to be able to provide a tool that we're really proud of. And again, please feel free to contact Justin and I. Justin, do you want to talk about some of our future work and goals with FileTSAR?
Yeah, while we're waiting for a response, I think just want to talk to you about some of the visions we have. One of the things we realize about the FileTSAR for now is a lot of small agencies find out the hardware needed to make the FileTSAR running is too expensive. And so we're looking at the technical solutions, try to make the FileTSAR a little bit more scalable. And we already have a very good idea how that works. But main idea is trying to switch from the virtual machine images to the Docker containers. So going from there, we can make our tool a lot lightweight and a lot more scalable. So making it lightweight is just only one direction. The design we have can actually also make it, be even bigger than the existing FileTSAR. So I think there are some of the technical solutions that we're looking for to make this utility to be able to available for you, regardless how big your agencies are. You might be able to find a tool that's relevant. So this is something that we've been currently working on. Kate and I, we've been working on this, and we also submitted a proposal to NIJ and waiting for the response. So with that, I want to turn this over to Kate.
Yeah, Josh, do you have any feedback from the poll question?
No, so it looks like silence is a good thing.
Hey, as a professor, silence is usually a good thing.
We do have some questions that have come in, but we can save those for
Yeah.
the Q&A session.
Yeah, that's great. So again, Justin and I want to thank everyone for attending. Thank NIJ for funding FileTSAR project, and then also kind of reiterating what Josh said earlier, that the opinions, findings, and conclusions or recommendations expressed in this presentation are that of Justin and I, and definitely not of those of the U.S. Department of Justice. But yeah, I think Justin and I would love to take questions.
All right, so we, as you see on your screen now, both Dr. Yang and Dr. Siegfried Speller have given their direct contact email. So do make sure you take that down should you want to reach out to them after today's event. You will also find a PDF version of today's slide deck that is back on the main event page. So you can also download that before you go. That way you can have their email or direct email contact information as well as today's slides. We are also recording today's event, and we'll be converting that into our archival version over the next few days. So the first question came from one of our international attendees today from Italy, asking if it was possible to get a demo in order to check the opportunities and possibilities before they go through all of the licensing agreement to make sure that it is a good fit for their agency.
Yeah, so that's something we've actually had a request from other agencies as well, and was going to be something I worked on prior to COVID hitting. And so, yes, we will be putting together a demo, and we would be happy to share that. Happy to do that.
All right, perfect. Next question comes from Eric asking, what are the current technology specs required for FileTSAR, and what is necessary for the program to be able to run there at their station?
Yeah, that's you, Justin.
Okay, so right now with the way how we set up the system, we have a we configured 8 terabyte server hard drive configured as iSCSI storage, and that one, so there will be a storage unit. It's going to be huge, and the bigger chunk is going to be the networking portion. So you have to have faster networking to be able to capture the data. So our current setup is a 10 gig output, and with individual port supports 1 gigabits of input. And I think the biggest challenge is the processing need. So if you need something real time, you're going to need tons of RAM and very heavy on the processor side, because real time analysis is going to be very processing consuming. But if you're if you can take maybe a day or two waiting for the analysis, so a traditional Xeon processor, two or three of them should be more than enough. But the RAM we had in our lab environment is 128 gig, and that was able to handle 100 gig of big data. Still needed 1 hour of processing time for 100 gig of data to reconstruct all the different files. I hope I answered your question.
All right, so Catherine, since you still have the control of the slides, we did have one of our users ask if we could repeat the poll question again. I think that's a fantastic idea if you want to scroll back there. So does FileTSAR fit your agency's network forensic investigative needs? And if not, what suggestions would you have? So this is the opportunity for the audience to give some valuable feedback to our presenters. While we're waiting on those answers to come in, the next question we have is, what is the max size of the analyzed file possible? And if the file is too large, I know you just mentioned 100 gigs, is it capable to work with file chunks?
To answer that question, I think it's possible. Right now, it's not implemented that way. Right now, the single file is only up to 2 gigabytes. I think it was because of the limitation on the TSAR side. So put differently, the TSAR was only able to capture each different chunk to 2 gigabytes, I believe. So anything more than that, we have to do a little bit of manual stitching. It can be done, but it's not in the current system because we didn't get kind of a request from the user to say they need processing 4 gigabit of a file. So we're looking at single file a single file size, not the total size of the files.
All right, and we do have just about a minute or two left, so we'll see if any questions do come in. While we're waiting on that, I want to give the microphone back to our presenters just for the last bit. Just really, Catherine and Justin, where do you see your program going? In the short term and also in the long term. What are your goals for FileTSAR?
Kate, this is a question for you, Kate.
Yeah, so as Justin mentioned, we created FileTSAR, and we were confident that it met sort of the challenge posted by NIJ, but then we also received some great feedback from law enforcement that there were other needs as well. And so again, that's why we posed that question to the audience. If there's something that you think we're missing, Justin and I would love to hear about it, because the tools that we develop and the research ideas that we have often come from the real world user. And so we don't want to make anything that's not beneficial to the community. And we realize that law enforcement is incredibly diverse, especially digital forensics, from kind of the one-man shop to much larger RCFLs. And so again, any feedback you guys have, we greatly appreciate it. Please send us an email, anything. I think that's really the future, is as technology changes, and as you guys have new challenges, we'd love to hear about them, because we would like to be able to develop solutions.
All right, perfect. So we did have a couple of other questions come in. We can end on those. So this is another question from one of our international users. So this could definitely help kind of mold away and understand how this could be obtained. But once they fill out the licensing agreement and everything is approved, do you provide training? And with international users, how exactly would that work?
Oh, great question. So because we wanted this to be easily accessible to as many agencies as possible, we developed online training modules. And so that is how it's all going to be accessed through a secured website. So once you complete the license, I will give you the link and the password. You'll log in. You can download all the training materials. They're divided up into sections. So you'll have a training on how to reconstruct the files. You'll have a training on different parts of the visualization. And then that way, if you need to refresh or go back at any time, it's really easy, and you'll always have access to those training materials. So all training materials are online.
Perfect. And then what kind of access would they have to you should they have questions?
Yeah, so we have FileTSAR@purdue.edu. And so that's an email that comes to Justin and I and a couple other members of the research team. And so we are always there to answer any questions that people have. Absolutely.
Perfect. So we'll end on this last question. As of what one of the users has seen, this is a very great program. Are there any recommendations as far as training for basic network forensics in reference to getting data before putting it into FileTSAR?
Oh, wow. So there's going to be, IASIS always has some great training, although it's traditionally in person. And so with COVID, things have been quite interesting. That training was usually hosted in April. There is training at the National Computer Forensics Institute in Hoover, which is a suburb of Birmingham, Alabama, that the Secret Service puts on, and that is free to any law enforcement in the United States. That is definitely a program. They have a great network forensics training session that I would absolutely recommend if you can get into that.
All right, perfect. And with that, we are at the end of our webinar time for today, so we will go ahead and close out our event. Obviously, the first thing we would like to do is to thank our subject matter experts, Dr. Catherine Siegfried-Speller and Dr. Justin Yang. So thank you both for joining us today and the countless hours and research that you've put into FileTSAR.
Thank you.
Thank you.
We would also obviously like to thank all of our attendees for joining us today and all the interaction and questions that you had for our audience or for our presenters. These webinars are just simply not possible without your attendance and your support. So thank you everyone for joining. Before you leave today's event, we always ask that you participate in our short survey. You will find a link to that directly below the closed captions pod. Simply click the word survey and that will open up a new window for you. Your feedback is about our webinars is always vital information that we make sure we are using to provide you the best webinar experience and adjust any content as well as the way we disseminate that information out to your audience. So if you could take a few moments to do that for us, we would greatly appreciate it. You will also see in the chat pod, Tyler is going to be posting links to our social media outlets, Facebook, LinkedIn, and Twitter. Make sure that you are following us there to stay up to date on all of our daily activities. He will also be putting our website as well as podcast information up there as well. On our website, you will be able to find all of our no-cost webinars, reports, and success stories that we are constantly putting out through the FTCOE. And then our podcast season, you will be able to find new episodes there as well. Again, we do want to thank everyone for attending today's event. Make sure that you do download a PDF version of today's slide deck back on the main event page where you came into today's webinar. And we are recording today's event and we will be converting it into our archival version over the next few days. Should you want to reference back or pass along to any colleagues that might have missed today's live webinar. Again, please make sure to complete our survey. Make sure you check out our website. We're constantly adding new content. And we want to thank everyone again for joining us for today's webinar, both nationally and internationally. We hope everyone has a great rest of your afternoon.